This is a hard problem. It looks similar to the previous two methods on a string question, but the pulley here makes it trickier. Feel free to pause and try it on your own first. This is a Newton's second law problem because there's acceleration mentioned, so we are going to use F equals to ma. Let's slow down and separate forces into two buckets, individual forces and the resultant force. First step, I'm going to treat M1 and M2 as one whole system. Remember, in the combined system view, we do not include tension. We are told that M2 accelerates downwards at g/2. That means the whole system accelerates at the same rate of g/2. By the Newton's second law, the resultant force on the whole thing is the total mass of m1 plus m2 times the acceleration g/2. Now, which individual forces create this resultant force? On the diagram, m2 experiences a downward weight. Let's label it W2. m1 experiences a downward weight as well. Let's label it W1. Does it mean both individual forces are downwards? Think about it. The answer is no, because the pulley is changing the direction of the force. This is the trickiest part. The pulley's job is to change the direction of the force. If we simplify the diagram by removing the pulley, we will see W2 acts downwards and the W1 acts upwards. This is because the pulley changes the direction of W1. So for the combined system, we have two individual forces, W2 downwards and the W1 upwards. As we define downwards as the positive direction, W2 is positive and the W1 is negative. That gives a net force of W2 minus W1. Here we've got both pieces now. The individual force W2 minus W1 equals to the resultant force M1 plus M2 times g/2. It turns out one equation is enough. Although we have two unknowns here, M1 and M2, the question only asks for the ratio of the two unknowns. So we will skip the single object view this time. Let's take a step back and plan for the question. This two objects connected by a string type of question usually requires the students to apply the Newton's second law to the combined system and a single object. We went for the combined system first, identified both individual forces and the resultant force, and constructed an equation. Since one equation is enough for this problem, we did not continue with the single object view. But if you encounter a problem in which one equation is not enough, just go for the single object view. Now let's walk through the solution. Apply Newton's second law and put down the basic equation F equals to ma. In this problem, the resultant force on the whole thing is W2 minus W1. And then this makes the total mass of M1 plus M2 accelerates at g/2. Expand W1 and W2, do the algebras, and we get the ratio 1/3. The answer is A. Here is the key takeaway for this lesson. First of all, pulley changes the direction of individual force. In this question, the pulley changes the direction of W1, but you can approach the question in another way and make the pulley change direction of W2. You will get the same answer as long as you're consistent with the direction and the signs throughout your working. Second, the general approach to this problem type is to apply Newton's second law to both combined system view and the single object view, and construct two equations to solve for the two unknowns. But this question only asks for the ratio of the two unknowns. That's why we did not proceed to the single object view stage. If you have any questions, please leave them in the comments.